In this video, we're going to examine what the scale factor has to do with the ratio of the perimeters of similar figures. And so let's begin with a little bit of review, hopefully, and figure out the scale factor between these two similar swimming pools. So to find scale factor, I need to find two sides that match up and both have numbers on them. Well, in this case, it's going to be the bottom length of the swimming pools. So my scale factor is going to be 50 over 40, which I'll of course simplify to. I always simplify to 5 over 4. And so my scale factor is 5/4. The bigger pool is 5/4 times as big as a smaller swimming pool. I can use this now to find the width as we did in the previous video if you watched that one. I'm going to set up a proportion beginning with my scale factor 5 over 4 and then match that up to the other two corresponding sides. Well, since the bigger number went on top, the bigger number being from the left swimming pool, I have to make sure that 25 also goes on top. I have to be very consistent when I write my proportions, and that's matched up to the side I'm trying to find, that length right there, the vertical side of the smaller pool. So cross multiplying to solve this would get me 5x equal to 100, and then dividing both sides by 5 gets me a width of 20 meters. So I can figure out the smaller swimming pool is 20 meters high. Well, let's go ahead now and take a look at what this has to do with perimeter. Recall that perimeter means the distance around an object. So adding up the distance around the large swimming pool, I've got 50 plus 50, and then a 25 and a 25. Adding all that together gets me a perimeter of the large swimming pool of 150 meters. If I do the same thing on the smaller swimming pool, now that I know the width is 20, I'm going to add up 40 and 40 along the top and get 80, and then 20 and 20 along the side and get a perimeter of the smaller swimming pool of 120 meters. Well, something very interesting happens when you simplify that fraction. It turns out that fraction, that ratio, also simplifies to 5/4. So it turns out that our scale factor and our perimeter ratios are always going to be the same thing. Let's take a look at how we can use that to solve a new type of problem. So what we just discovered is that the scale factor between similar figures is the same as the ratio of the perimeters. So let's go ahead and take a look at at this example. The question this time is to find the perimeter, the distance around the smaller figure. Well, you'll notice I'm missing several sides in that smaller figure. In fact, I only know one of them. And so setting up several different proportions to find all the missing sides and adding them up would be one way to do this problem, but it would be a little bit time consuming. Here is another trick that we can use. Let's begin by finding the scale factor between the two figures. To do that, I need to find the two sides that match up and both have numbers on them. In this case, there's only one option. 10 and 15 are the two sides that match up. So setting up that ratio and then simplifying it gets me a simplified ratio, a simplified scale factor of 2/3. Well, recall what we just learned. Not only is that going to be the scale factor, that's also going to be the ratio of the perimeters. And so what I can do is use this as a shortcut to find the ratio, or find the perimeter of the smaller figure. So let's begin with a proportion, 2 over 3. Now, instead of setting up a single side, like this problem may tempt us to want to do x over 18, rather, what I'm going to do is just find the perimeter of the larger object. And so adding up all 5 sides of this object, 15, 9, 12, 15, and 18, I come up with a perimeter of 69. Now, since that is the larger perimeter, the bigger figure, that needs to go on the bottom where the larger number is located. Now, even though this is a scale factor we just learned, it's the same as a perimeter ratio. And so then putting p in the numerator, which would stand for the perimeter of the smaller object, I should be able to find this perimeter without having to find all individual sides. So it's a great trick, a great alternative to having to find all the sides of the smaller figure individually and then adding them together. So cross multiplying gets me 3p equal to 138, and then dividing both sides by 3, I end up with a perimeter of the smaller figure of 46. And since I don't have a label, I'll go ahead and throw units on it. So once again, I set up my scale factor, and since I knew that was also the same thing as a ratio, as a perimeter ratio, I found the perimeter that I knew, and I could do a proportion to find the perimeter I didn't know.